So we're looking at scientific notation and making sure there are forms that look like scientific notation that are not scientific notation. So working with non-standard forms and other number times power of 10 and how to get those to actually be scientific notation. So scientific notation is a number times the power of 10, but that number very specifically has to be at least 1 and less than 10. Or in other words, it's going to be one digit before the decimal point, or if there's no decimal point, there'll just be one digit that is not a zero. So if it's 0 point something, it's not scientific notation. If it's multiple digits before the decimal point, it's not scientific notation. If it's just a single non-zero digit with no decimal point, that's fine, that's scientific notation. So that's something to watch for with scientific notation. Is just because it's a number times the power of 10 does not mean that it is scientific notation. So as an example, we have some numbers here that are numbers times the power of 10. And looking at this first one, there's too many digits before that decimal point. So this one is not scientific notation. So if I write this out, it's 21.5 million. It's 21, comma, 5, 0, 0, and then my other zeros. So to put this into scientific notation, instead of having the decimal point here between the 1 and the 5, I need to have it after the first non-zero digit. So it's an extra place over, and I now have 7 places rather than 6. So that's 2.15 times 10 to the 7th power, as I had to move that decimal point one more place, and then my power of 10 went up by 1. 8 trillion, 8 times 10 to the 12th. There's the unwritten decimal point. 8 is between 1 and 10. There's one non-zero digit. That one is fine. That one is scientific notation. 0.834 thousand. 0.834 is less than 1. The number before the decimal point is a 0. This one is not scientific notation. 0.834 times 10 to the 3rd power. To get that back into standard form, we would move that decimal point 3 places. So it would be 834. Scientific notation would place that decimal point after the 8. So 1 place over from where it was. 8.34 times 10 to the 2 power, because there was 2 digits then after the decimal point. So again, the decimal point had to move 1 place smaller, and so the power of 10 is 1 smaller. So let's look at some more examples and work on doing this adjustment from a number times the power of 10 that's actually not scientific notation, getting that to be scientific notation without even having to write it out in standard form. So what's going to happen is as you move the decimal point to where it should be, you have to adjust the power of 10. However far you move the decimal point, that amount has to be either added or subtracted to the power. Now, if the number starts out too small, that means the power was too big and we need to subtract from it. If it starts out too big, the power wasn't big enough and we need to add to it. But you have to be careful with negatives because in this case, too big would be not negative enough and too small would be not like too negative. So when we add and subtract with a negative, it has kind of an opposite effect. But starting with 0.034 times 10 to the 16th, we need that decimal point to be after the 3, so that's 2 places. This number was too small, so we're going to a smaller power. We're going to subtract 2 from the power of 10. So balancing, anytime you remove the decimal point, that has to be balanced by some sort of unit change, in this case, changing the power of 10. So we're going to have 3.4 times 10 to the 14th. Then 13.4 times 10 to the 12th. That number is too big, so I need to move that decimal point. I need to have 1.34. And that means I need a bigger power of 10. I need to add 1 corresponding to the 1 place that I moved the decimal point. So we have 1.34 times 10 to the 13th. Then 0.27 times 10 to the negative 3. The number is too small. I'm moving the decimal point 1 place and subtracting 1 from the power of 10 to get a smaller power, in this case a more negative power. So this is 2.7 times 10 to the negative 4. Negative 3 minus 1 is negative 4. And then 124 times 10 to the negative 12, the unwritten decimal point there at the end, it needs to instead be after the 1. So that's moving 2 places. It was too big, so we need to add 2. We need to make that power bigger by 2, in this case, less negative by 2. So we have 1.24 times 10 to the negative 10, as we do negative 12 plus 2. And then going on to number 6, kind of putting it all together to be able to go from a standard number name form or even a non-standard number name form and get to scientific notation without having to rewrite it out in standard form with all of the zeros. So the first step, you replace the number with the power of 10. So 217.8 million becomes 217.8 times 10 to the 6th for the million. And then we make our adjustment. The decimal point needs to be after the 2. So I need to go 2 bigger than the 6. So we end up with 2.178 times 10 to the 8th power for the scientific notation form. So it's 100 million rather than just million, so that would be the 10 to the 8th place value. 0.83 trillion, if I rewrite trillion as times 10 to the 12th, but we're actually not quite there. We're less than 1 trillion, so I move that decimal point 1 place over and subtract 1 from the power of 10 because we're 1 place below the trillion. And it is 8.3 times 10 to the 11th power.